Welcome, everyone, to this new episode of Among Us, human robot teaming. I'm very excited today because I have a very special guest from Romania, Professor Marius Leordeanu. And you will see, our listeners will immediately see that there is a very clear connection between the topic of human robot teaming and the research of Marius, our guest today. Just to remind ourselves the concept of human robot teaming. Human robot teaming means a very close level of collaborations between humans and robots, humans and machines. And this level of collaboration involves sharing space, physical space together, sharing forces, like, for example, almost poetically dancing together, a human and a robot, and also sharing decisions. Who is in charge? Who is the leader? So, welcome, Marius. Would you like to say a few words to our
I'm so
listeners?
happy to be here, Filippo. Thank you so much for inviting me to your very special podcast. It's a great initiative, a great project, and I'm so happy to be a small part of it. And I want to salute all your, say hello to all your listeners, watchers, and friends, and everybody who's connected to your channel. And I hope to have a very nice conversation with you. I'm so happy to meet you and to see your very nice background behind. This is such a special place there in Norway in Kristiansand. This is great. I cannot wait to come back there.
Yes, I know you have visited us here, and you were in Constilo Museum.
Yes, we went there a few months ago with a very nice project. I cannot wait to tell you about it.
Very cool. So
Yeah.
for our listeners, I would like to actually introduce Marius more formally, reading his biography. It's a real pleasure to have you here, Marius, professor in computer science at the University Politecnica of Bucharest. And also, Marius is a senior researcher at the Norwegian Research Center, NORSE. So we have another connection here, I see. And a researcher at the Simeon Stoilov Institute of Mathematics of the Romanian Academy. And here, actually, my curiosity already starts triggering when I read mathematics. How does it connect to your research? I'm sure you will tell us a little bit more about this link. And
Oh,
you have earned a PhD in robotics from the prestigious Carnegie Mellon University. And you have built an internationally recognized research career at the intersection of machine learning, visual perception, graph optimization, and autonomous systems. Actually, Carnegie Mellon, it's really interesting to me because my research group is designing a new snake-like robot, and Carnegie Mellon, there is a group there actually,
Howie
very
Fawcett, I think. Wasn't
exactly.
he? Yes, he was creating these snake robots, which were amazing. Yeah, this is really good for search and rescue, for getting into places that it's hard to get, all kinds of situations, right?
Exactly. We are using it for mostly for search and rescue operations, and also for inspection and operating in situations where other robots with wheels or robots with tracks cannot access, like tunnels or narrow
Mhm.
corridors and things like that. So it's really nice to see that you graduated from Carnegie Mellon University, and actually your research is quite it covers a quite wide range, from unsupervised learning to space-time reasoning. This is also very interesting. I think it connects really much, quite much with the concept of human-robot teaming. You have worked with aerial scene understanding, visual perception for autonomous systems, and the integration of vision with language. This is also incredibly related to the topic of this podcast. And you are the author of the book unsupervised learning in space and time. And you have received several awards, including the Romanian Academy's Grigor Moisil Prize for your contribution to graph matching and machine learning. And this, I think, it was given by you by one of the top computer science and mathematician in Romania. Is that
Yes,
correct?
that is correct. So Grigore Moisil, on one hand, was one of our top computer scientists in the history of our computer science and mathematics, Romanian mathematics and Romanian computer science. So Grigore Moisil is at the top. And then I was very honored and happy to meet Solomon Marcus, who's one of our top mathematicians of all time, who actually insisted in giving me this award. And I'm so honored and so happy because Solomon Marcus, an academician, he was also working at the intersection of poetry and arts and literature and mathematics, trying to see this connection. He was beyond just mathematics. He was beyond your standard, let's say, researcher. If there is anything like a standard researcher, he was way beyond. Greater than life, like this person was just amazing, and I was very happy. Usually, this prize was given to several
Intersection of poetry and
and
mathematics.
mathematics. He was a revolutionary in this sense because he wrote this intersection of two fields that apparently are so unrelated, right? Like poetry and mathematics. Even though we do have a mathematician, Barbu, who is also a poet. So I think there is a lot of connection between art and mathematics, of course, even though apparently there is no connection between them, but they are deeply connected. In the same way, music, if you want, is connected to mathematics, in the same way is connected to our souls, right? To our emotions and feelings. In the same way, computer vision, right? Vision. I do computer vision, I do vision. The first time I heard about vision, I was like, wow, this is science fiction. How can you connect vision to mathematics when vision is like our most natural way of perceiving the world? It's who we are, right? Vision. We look at the world through our eyes, and how can you connect that to an algorithm, to a program?
Mm.
So there are a lot
Very,
of deep
very beautiful.
connections,
Like
right?
I see
Excuse
a lot
me.
of very beautiful connections and analogies between
Um,
art and mathematics
well,
and
this is
music.
what intelligence does, right? It connects all these different ways of seeing the world, perceiving it at different levels of semantic understanding and feeling. I could think now even of this concept of synesthesia or ideesthesia that connects ideas to how we sense them, and the mystery of consciousness, right? How do we put everything together in this apparently simultaneous way of putting them together in this space, highly dimensional space in which we exist, in which our consciousness exists. So it's a mystery. It's amazing, and it's amazing today to see that machines start to resemble, to be a little bit like us, which is so exciting because I mean, this connects to everything I do and to my deep drive for this. Because when you look at the robot and you are thinking, and your theme is meeting robots, meeting people, people meeting robots in this meeting space. What are we going to do now? How are we going to live together? How are we going to share the space and time? And what is this connection, in fact? So my perspective is, I think, just follows naturally. So one hand, why am I excited about AI? On one hand, I'm excited because I can see this. I mean, artificial intelligence, right? It's not that artificial in the sense that it's made of these pieces of the world, right? I mean, it's the physical world, and we are all made of this physical world. We are all parts of it. So it's not artificial. It's a natural world which we use to create this intelligence. On one hand, well, is it really intelligence? That's a different question, but
Mhm.
it's not necessarily artificial. It is natural because it's physical. And if this physical world, which is outside of ourselves, right, it starts looking out like ourselves, it's like a mirror of ourselves, not in the way it looks, but more in the way, it could be in the way it looks, but what's more interesting is that it's a mirror of ourselves in the way it thinks and behaves, and it's learning patterns human patterns, right?
Mhm.
So if this physical world can imitate us, can learn our patterns, that means that the physical world is a little bit like us, right? I mean, it has this potential. On the other hand, we are like the physical world, because if we look, if you look at the microscope and you look at the brain at the microscope, you see physical matter. You don't see thoughts. I mean,
Mhm.
you cannot find Marius if you look by on the microscope, looking at every neuron in my head and asking that neuron, "Hey, do you know who Marius is?" And probably that neuron's like, "Bip bip, I don't know what you're talking about." So where is Marius, right? But Marius is somewhere there, right? So it's interesting because on robotics and AI, I think makes us understand better that we are part of the world and the world is like us and we are like the world. So this is very deep. It's more like I get a better sense of belonging to the world. It's like connecting a bridge, a stronger bridge between us and the world around us. And I do not see necessarily robotics as a partner, but rather I see it as an extension, as like the ability to for the humanity to go outside itself, to reach outside and
Mhm.
realize, and for the world to come inside. It's almost like transcendence,
Mhm.
because it's giving me the possibility to extend my imagination and creativity and go beyond myself.
So
At the same
a way
time,
to augment
yes, and at
humans.
this, yeah, because robots give me better eyes, right? I can see from the sky, or I can use snakes to go inside and discover things. It gives me eyes. It gives me the capability to fly. It gives me the capability to be in several places at once. Now, I don't have full control over it, and that is okay, because I'm not in full control of the world in the same way the world is not in full control of myself. So that is fine. We don't have to be, that much in control. We should be like, as you said, in this dance. But it is through dance we can transcend. I think it's a opportunity for us to, by automatizing things, by learning patterns of our things and using them in this automation systems, and then this will give us space and time to invest and increase our consciousness, our understanding. Now, of course, that for a lot of people, and these are the dangers of AI today, and for a lot of people, AI becomes just a replacement. And this is not a good thing. Because, okay, so whatever I was doing before, now I can just tell Claude, look, write me code for this, do my job. And
Mhm.
then it's just an invitation for us to be more lazy and not think and not do work, or not, just be
And also
less in understanding what's going on.
the creativity part there is completely missing.
Yes, we will just lose if we go that way. But
Mhm.
it's a gradient, right? We are on a slope, and every gradient gives the possibility of going up or down. So the gradient it could be a powerful positive thing or a powerful negative thing. Because if I
Mhm.
go the negative gradient, I will
Mhm.
fall. If I go along the positive gradient, I'll grow. So
Mhm.
AI, it's dangerous, and at the same time is a blessing. It's a
Mhm.
blessing if we go to the right direction. If
Mhm.
we use it in order to give ourselves more space, mental space to think, to understand, to use AI indeed as a partner, if you want, or as an agent, as an extension for
Mhm.
us to have more time to think, for us to have more time to realize what's going on, but to understand, not
Mhm.
to reduce our understanding, but increase it, increase
Right.
our creativity, increase that part which cannot be yet put into patterns.
Very good.
So I really don't want a robot to replace me. And people people sometimes show robots versus people. And you have this image like man versus God, man versus robot, robot versus man. I don't see it that way. I see robotics as a way of increasing humanity,
That's
of
why
increasing
uh,
consciousness.
the idea of teaming, right? We are teaming up.
Yeah,
Like we
teaming,
are
exactly. Teaming between me and robots is like teaming between my mind and my body. See,
right.
my body is just a robot, right? And that's why robotics is so useful for our bodies. If if an accident happens and we lose a limb, we can replace it with a robotic arm or a robotic leg, and it works better and better, and we get used to connecting it to our bodies. So we are almost by birth, we are connected to robotics.
Mhm.
We are minds and robots from the moment we are born. I mean, if you look at this intelligence and human intelligence, it could be, I see it as above all intelligence on Earth, even though it could be dangerous. Also, it's a dangerous part of intelligence, of course, but it is the one that became more conscious, let's say. But from the beginning, we were connected to this. We have this natural inclination to use technology, to develop technology. If there is anything that differentiates us from other living beings, is the ability to create and use technology. Like
Mhm.
there is, I mean, you have a lot of mammals that have language. Monkeys have language, birds have language, but not so many have technology. In fact, monkeys have some kind of, primates have some kind of technology, very limited, but we are the only ones who truly create and use technology. So
Mhm.
technology, you could say, is in our DNA. Technology is human.
It's a really interesting point. You know, we started with the possibility of having an opposable thumb, right? Then,
Yes,
thanks
yes,
to this, we managed to build tools, a
yes.
hammer or
And
any.
our body, which is our basic robot, without it, we wouldn't exist. Our consciousness would not exist. Like the way I understand the world is all through the perspective of my body. If I say if something is far or close, if I say if it's cold or if it's hot, if I say if I can reach something or not, like everything I see around me, my perception is deeply connected to my possibility of acting in the world.
Mm.
And
Well,
the way I
Marius,
act is through my body.
this is a very important point, the perception part. And this
The
was
perception.
actually my first point of discussion with you. You very nicely reached it. So I would like to dig a little bit more into this concept of perception and ask you what is, in your opinion, how perception could be the foundation of this concept of human robot teaming, how important
Uh,
it is. You mentioned about the possibility of using vision, right? Or but also other kind
Perception.
of sensors like force sensors, to have this completely smooth interaction between humans and machine,
So
and this
perception.
identity, creating this identity, as you mentioned.
Yes, perception is a very important subject. Perception, initially, when we think of it, we might think of it at the level of sensors, eyes or temperature or forces. We have sensors that perceive. But in reality, if you think more about it, you realize that perception exists at many levels. And the same scene, the same thing has a different meaning at different levels. It's not like perception, like even our vision, right? And let's think about vision, because vision is just a perfect example. It's feeling our reality, and it's just a great part of perception. It's vision. If we look at an image, maybe at the beginning, before think before we think more about it, uh, we can think that perception is just what I see with some meanings attached to it, like a semantic segmentation. But in reality, and we didn't even reach that point yet in computer vision, in reality, it's an ocean of levels. It's so deep and so high, if you want. There are so many levels that happen at the same time. And it's only our mind that puts a limit to these levels. For example, let's look at this, at our image right now. If I touch this, I touch this point. Now, what meaning can I attach to it? Now, at the very first level, I could say, well, this is just a dark point, a dark pixel. So before I develop vision, that's exactly how I see this image, just full of pixels that make no sense. Like a matrix full of numbers, make no sense, no connection between them. And then at the next level, then I start seeing, oh, but this is also part of a material, the material in which my shirt is made. But
Mhm.
the same point is also a shirt point, a
Mhm.
point of a shirt. So it has a meaning now beyond the material. It's also a point on Marius. It's actually a human point, because, at any point you put, it's also a color, a material, something like a tissue, a person. And at the same time, if you put your point, it's point of my room. It's a point of, It's a point of my city. It's Bucharest. You touch Bucharest now. You actually touch Earth. And now, if you go in time now, you could say this is not just a point in time, in space, this is also a point in time. It's a point in our discussion. You touch the podcast.
Very
It's
nice.
actually a point that I make. So the same point could be seen, could be perceived at many different levels. And let's assume that in some very nice, fortunate case, this discussion becomes, I don't know, the beginning of a collaboration between the two of us.
I
Or
hope
the
so.
beginning of a nice friendship, or something that we create together. And maybe now we decide to create something together. And then this point will be not just part of this podcast, it will be the beginning of something important. It's like it's like a dinner between two businessmen, and then this dinner, which initially appeared just eating, it became the establishment of something great, of a company or an empire or a bridge between nations, or the beginning of peace. It's so amazing that this level, it's just as metaphors. In fact, the more we move in this space and time at a larger and larger dimension, we realize that this segmentation, which initially was just referring to objects, could refer to stories, could refer to meanings at higher and higher levels. And it's truly only our minds that's the limit, and how we perceive things, right? Now, of course, that a cat has perception as well. But when a cat looks at the moon, it sees the moon, the pixels of the moon, maybe even better than I see them. I don't know. But in any case, it sees the moon. But definitely, it's not going to see the moon the way I see it. So up to a certain level, it's going to see this round thing. But it's never. But when I look at the moon, I look at it as a satellite of Earth. I look at it as a smaller kind of planet that goes around my planet. I know so many things. I could even think of Neil Armstrong touching the moon. I could think of people going to the moon. I could think of people going around the moon. I have so many images in my mind. The cat does not have that. A bird sees also the moon. It could have even less than the cat. So what is perception? It's just so amazing because it's so deep. It's a way of thinking. Now, let's think of a cosmonaut that goes to the moon, touches the moon, and comes back. And in fact, if you watch these documentaries with these cosmonauts, and when they say, "Wow, after I went to the moon, I've never seen it the same again, like I used to see it. It was the whole world's changed." Like when I look at the moon,
Different
of
perspective.
course,
Yeah.
because you have been there. That is your place, also.
This is
None of us
very, very interesting. And also the concept you mentioned metaphors. And actually metaphors are at this time where we live, like, we have seen this amazing development of artificial intelligence and machine learning algorithms, but metaphors are still challenging for machines to understand. For example, if I tell you, I kill you, most of the time I don't mean it. I mean, but a machine, how can a machine understand
Yes,
the
exactly. Because
difference? Yeah.
and this also connects to language, the connection between vision and language, right? Because we were touching in our conversation earlier, we were thinking of discussing about that. So language and vision at some point are developing together, because vision. I learned how to separate objects. Okay, so this is a cup, this is a physical object, but then the word I see also means I understand. So let's
Very
say
good
I
point.
say the following. I walk on the street and I see two people talking about this World Cup game in which Messi scored 3 goals. Now, how can you see that? Now, if you really, really are talking about very low level perception, you cannot actually see how people talk about this game. But if you think of seeing in a higher level sense, you can actually imagine this conversation, how you see these people talking about something. So that seeing includes the story behind, includes the talking. It's almost like at some point, language developed together with vision. And as language developed, also vision developed as well. because for example, as we become more mature in life and we are more experienced and we have seen, we have more experiences of life, more stories of life, we see things differently because we give deeper meanings and deeper connections between what we see and what it is right there in front of us. It's almost like a doctor looking at a certain pattern and already seeing the disease or seeing something way beyond what we can see. The same
Now,
way.
Marius, you are already touching a point that I also wanted to highlight, which
Yeah,
is
but let's
the
go to language. Let's go a little bit to language, because I think
language. Yeah.
that language and perception are tightly connected, because I think that at some point, in order to further develop our vision, we need language, because language brings meanings to a high level, and also language gets its insights from visualization, from visualizing the world. Like when I say a story, I'm also visualizing. So I could, in our work, in my work with a student, he was graduating in a few months with Nicolae, and with another student, Mihai, who was graduating a few months ago with
We will add
PhD.
some links in the description to your work and the
Yeah,
work
Mihai
that you make.
Mashala, Nicolae Kudlenko. So with them, we try to find this common space between vision and language, and we designed, I imagine, this graph of events in space and time. I was thinking that at least we could represent stories, try to represent stories as graphs of events in space and time. Why events? Because events could be like units, space-time units of change, different levels of change, in which themselves could be stories if you expand them, which by relating to other events and in even high level ways, not just like spatial and temporal ways, they could create stories which could then we could describe in language, or we could visualize. So I think there is a common space in which language and vision live together, and through language we improve our depth of thinking, if you want. Now let's go back to robotics. Now robots start being able, from a mechatronics point of view, if you want, or control, being able to have our movements. Like we see humanoid robots having perfectly, almost imitating our movements, having balance, being able to run. So they do have this level of human behavior, but they don't have the higher level human behavior, like understanding when you say the metaphor, oh, I kill you, or, of course, that we understand this in context, or the
Mm.
jokes, right? What is a joke?
A
and
joke
and
or
catch it in the context, right?
humor
Some,
or
some,
love or concepts that are
they
transcending.
they cannot, unless they imitate us, unless we just give them all our patterns and they just imitate us. They cannot really get everything unless they either imitate us and they are just perfect imitators, or they live in this world to actually start getting all these things. Like and not everything it is as it appears to be, right? It could have different interpretations. For example, and again, this is something is not touched yet in research, unfortunately. I see a clown in the middle of an intersection. Okay, now there is a lot of research in abnormal events detection, right? Now I see a clown in the middle of an intersection. Now, is that an abnormal event or not? So the clown is in the middle of the intersection. Normally you would say it's an abnormal event. How about if I tell you now that the circulation was stopped, and actually the clown is part of a performance in the middle of an intersection with people, but you didn't see them initially, with people watching from the sides and everybody being there. It's all approved by the mayor, whatever, and it's a part of a show.
Like
How about
yeah,
if I tell you that the clown is actually part of a movie? It's a Steven Spielberg's latest movie that's just catching all these with these camera angles. This clown is part of a movie, so the clown is about to do something in the movie. Is that an abnormal event or not? Inside the movie, it's an abnormal event, but in the real world, because it's part of a movie, it's part of a set, a movie set. It's not abnormal at all. Or if the clown is part of a concert or is part of a performance, it's not abnormal at all. So what is abnormal or not? What is the interpretation we give is part of a higher level context. And it's only the mind and the level of the mind and the understanding in the larger space and time context that we can actually understand things. Because initially, if we're not smart enough, we can think, oh, he's a killer. He's a killer. And then we catch the guy and then we condemn the guy, and he's not a killer at all. Because we are biased. It's not bias. It's simply, well, you can call it bias, but it's a very small context. We didn't see the whole picture. So how are we going to make robots see the whole picture? Well, it depends. Do we want robots to see the whole picture, or we would rather use robotics? And I think this is more fun. To use robotics to help us, to extend our possibilities, extend, if we're missing a part of the brain, replace it. If I'm missing a part of my body, or if I want to extend my capabilities like this, if I want to be like Iron Man and try to do certain things I couldn't do before, go and rescue someone, or go through fire. I really, really don't know. I don't think we need human replacements. I don't think that. I think that I would rather have more fun and enjoy more my life, and use robotics to enjoy more my life. Like use robotics to create more interesting toys for children. Use robotics to go to places where people cannot go. So again, extra powers, dangerous places, or places to, in which we would not want to risk our lives to go. Use robotics to give us powers we lost, or improve powers we need. Now, would you say, wow, so you really want these robots to be your slaves? No. See, I actually don't want robots to be my slave. They would be my slave if I give them consciousness and life, and then I use them. But if I attach them to my consciousness, if I make them part of my body, they are not my slave as much, more than my hand is my slave. Is my hand my slave? No, my hand is not my slave, because I give life to my hand. I give life to my body in the same way my body gives life to me. So I think this is the dance. I honestly think that there are two directions in which we can go: the wrong one and the good one. The wrong one.
This is now about your vision. Nice. That's
Yeah.
nice to hear.
Okay. So I think there are two ways in which we can go: the wrong one and the good one. The wrong one is the one in which robotics steals our lives, in which robotics fills the world and we are getting out of it. It's almost like giving our souls to robots. It's almost like, oh, robots do everything we can do. So then why are we here? Like, why am I here for? If all the robots do whatever I do, they drive my cars, they do my things, they do everything. So the goal is not to replace ourselves. That, yes, it's interesting to create robots that can do what people can do, because it's our need for understanding what people can do. So we understand our minds by creating minds. That's the best way to understand things. So we have a hunger for understanding. And if I want to understand how something is done or works, the best way to understand it is to build it myself. So if I can build a brain, then I understand a brain better. And this is great. But do I really need to build brains that do what we do? No, I don't have that need. So that's the wrong way. But the good way is to actually elevate our spirit. It's to increase our brain, to increase our possibilities. It's like, we are the result of many parts anyway. It's a dance. Like every single part of me dances with every other part of me. And the dance is so perfect that it makes everybody think it's just one person, Marius, right? But it's a dance. Like when I'm talking, all these little neurons, none of them understands what's going on completely. But somehow in this dance, my voice comes out in a way that seems like a united musical entity, right? Made of many parts, which are voluntarily working together, because none of them is really suffering. They all want to stay where they are and live there. Now, I see, in some sense, through robotics, a way for us to transcend and become more spiritual and become more aware. And if we can automate something, let's do it. Let's automatize it so that we can have more freedom to think, to elevate, to be better artists, better teachers, better philosophers, better poets, better musicians, better people. better friends. So that is my vision. My vision is that it is humanity. And actually, if you look at things, if you look at the technology, right, even the phone, if I look at my phone now, is this phone less or more human than the phone that was like 40 years ago? This is more human. It's better suited for me. It's actually, as we can see, it's vision oriented and also touch oriented. So it's my hand and my eyes. It's easy to attach to everything I have. It's like so simple. It's not even a phone. It's more like a little extension of me. It's a window to my friends. It's a window to things I do. Now look at the phone from 40 years ago. Now,
Mhm.
was that was more robotic? That was more mechanical. That was less connected to my needs.
Uh-huh.
This is more human. It's not like I became a robot. The technology became more human.
Mhm.
Now, if we keep that in mind, I think we have a chance. I,
Very, very
I
interesting. Like also the idea of the example you just made. The phone is more human, and it involves. You said it's visual interface. It has a touch interface. It has auditory interface. You can hear music. You can listen to uh, the voice of your friends and so on. So this idea of gradually building an interface that is multimodal. It involves all the human senses. Maybe at some point we will also have an interface for the remaining senses, like taste or smell. I think that these are things that we could expect happening in the next future.
Yes, and I also so yes, exactly. So the phone is multimodal. The phone attached better to my mind and the way I think, but the phone does not look like a human being. It's in
Oh.
fact is devoid of shape. It's the simplest shape possible. So, but it is robotics in some sense.
Mhm. Yeah, it has
Especially
sensors.
if it
It
starts
has
reacting to me. If it starts reacting to me, so if I give input, if it processes and comes back with some output on its own, or it does some action, that is a robotic system,
Mhm.
even though it does not look like a human. So yes, I could see humanoid robots being useful in many situations. Definitely situations where we need humans and we don't have, like caring for the elders, or but also I see robotics in ways. In fact, robotics should, like any technology, because we shouldn't forget this. We pay for it, right? We buy it, we pay
Mhm.
for it, we give it everything. Like we actually do it because we need it. If we don't need it, we're not going to do it. So it has to address some of our needs. So besides the basic needs, we have the beautiful needs of creativity and intelligence, which is to make life more fun, to make life better, to make our world more friendly. So of course that I can see how all this technology and mathematics and numbers and things that apparently have no fun in them, no feeling, nothing. They slowly, when they actually reach a level of maturity, they end up into the places which are the most human, like entertainment, creativity, our everyday life. So I think that is the ultimate goal of robotics, to make life more beautiful, to give us more chances to create, to give us more chances to be aware and be more spiritual. This is amazing. But
This is a
putting more
beautiful
mathematics
message,
into
Marius.
technology, in fact, makes us more human. Excuse me?
But it's a beautiful message. I think that it summarizes the the discussion that we had today together with you. It's very interesting and it gives hope to our listeners for a better future.
So I still want to address a few points which connect to my work. So when I started at Carnegie Mellon, my first paper was on unsupervised learning from video. So it's space and time, because I was actually extremely curious about how the human mind or intelligence is able to learn by itself. And somehow I attached the idea of intelligence with unsupervised learning. Like, that is the core of intelligence, right? If someone is like figuring it out on her own or on his own. on their own, right? If I always tell someone what to do, that's not necessarily intelligence. So supervised learning is a fundamental part. It's important, but it's definitely just a little part. It's not intelligence, because it's not figuring out things on its own. It's the opposite, right? I need to give it labels at every single step. So unsupervised learning at its core is really the true face of intelligence. So what is the intelligence? What is the nature of intelligence? What is its driving force? And now, if you really want to, if you want me to express myself more freely, I would say that intelligence is deeply connected to life. So we were talking about hope and about a message, a positive message. Intelligence. Nobody, when we study artificial intelligence in school, nobody really comes to us and says, okay, guys, let's first figure out what intelligence is before we start doing artificial intelligence. Because we all talk about artificial intelligence, but nobody really talks enough about what intelligence is. And we call these systems intelligent before we even define intelligence. And that's a general problem with a lot of sciences anyway. Like, why are we talking about intelligence, but nobody actually explained to me, or at least we didn't do any deeper research into what intelligence is? Because intelligence is not just about solving problems fast. Because if it was about that, then we would have to declare ourselves defeated already.
Mm-hmm.
But we always find excuses and say, that is not intelligence. Yes, it's faster, but it's not intelligent.
Mm-hmm.
But let's say it. Let's say it. It's not intelligent. Why? And I think intelligence is connected to life. Why? Because there is one problem that life has to solve, which is surviving. And that is the hardest problem at all. In a universe in which everything changes, there is one thing that does not. There is one thing that goes the opposite way, which is life.
Mm-hmm.
So intelligence is here to solve the problem of life. So, and that connects also intelligence to consciousness, understanding.
Mm-hmm.
You have a mind in which this world exists, right? So the mind catches the shape of the world inside. But also the world catches the shape of the mind, because I cannot define the world in ways that are not conceivable by the mind. I cannot imagine things beyond verbs that I understand, beyond shapes that I understand, right? I cannot talk about colors I cannot see. I cannot talk about things outside of space and time. I cannot even talk about the word non-existence, because I cannot even I cannot imagine non-existence beyond the verbs of existence, which are inside, right? So there is a deep connection between mind and consciousness and existence, right? So I cannot just take this intelligence and say, okay, this is intelligent. Why? Because it's doing things faster. It's copying patterns faster. It's bringing me information faster. Okay, so what? At the end of the day, so what? It's not. See, in my mind, a mosquito is smarter than Gemini. And you know why it is smarter? Because the mosquito has the potential to change itself.
Mm-hmm.
The mosquito has the potential to survive. If some cataclysm happens, if some like comet hits the Earth, the mosquito has better chances of existing in 1,000,000 years or its successors than Gemini.
Mm-hmm.
Because Gemini is just plugged in into some electricity supplier, and it needs all our energy and all our effort and all our work to do what? To just imitate whatever we gave it. It's
Mm-hmm.
not even, it doesn't even know how to work with real sensors. It needs data that's already the output of the human mind. Like everybody says, oh, this is just training. Training on what? On text and images? Well, let's see. Who created that text? Human mind, right? So that is not input data. That's output data at the highest level of output. Who created those images? Humans, with a purpose. Like, the mosquito doesn't need that. You see?
Mm-hmm.
So I think mosquitoes are more intelligent And at the end of the day, mosquitoes are truly more intelligent because if you think about it, there are more mosquitoes and ants in this world than human beings, and they even say that their mass is actually like a quarter of the total living mass on the planet. So yeah, they are living. That's one thing. They are living. They know life. They know life. Yeah, they sacrifice the individual for life itself, but that's a noble thing. That's great. I mean, we all will pass away anyway. So really, we have to think deeper about what is intelligence, and we have to think deeper. Going back to perception at different levels, but perception with an intention. Because it's one thing to observe the world, but there is no point in observing the world if I don't have an intention. And we have an intention. You have an intention. I have an intention. The mosquito has an intention. The intention to live, the intention to be happy, the intention to create something, the intention to do something. Like doing is better than just observing. And doing with our hands, observing with our eyes, this has created the world, right? So the robot is not an observer. It could be a tool of intention. Not necessarily a tool. It could be itself have an intention if we put it in the larger combination of humans and robots, or it could be part of our humanity intention, like the robots that save someone from an earthquake, the robots that go and monitor the environment and help us have a better and greener planet, the robots that go into volcanoes, the snake robots that go and save victims or do all kinds of great things. They have an intention. Well, that might not be their individual intention, but they're definitely our humanity intention. They have an intention. They're not just there to observe. And I would even say that observance and perception without intention has no meaning because it's just impossible to observe without intention. Observing itself has intention because otherwise it's impossible to observe. Like, what am I looking at? Without intention, I have no attention. Without attention, how am I going to observe? When I'm looking at Earth, how should I see it? From what distance? Like should I look at the Earth from 1 million years, light years? How is it going to look like? Like just like a little dot, right? And we are all on that dot. So I'm not going to look at it right like that, even though it's seen like that from somewhere in space. So I'm going to look like that from my existence, which is directly related to the size of my body. And it's related to the size of my body, to the energy of my body, to the possibilities of extending my body, of reaching. Everything is related to my capabilities. And my capabilities are related to my intentions. So I think it's also connecting intention to perception and mind to body, robotics to intelligence, and all this together. And I will have to figure it out in this dance between
Very
people
beautiful.
and robots. This is
Very, very
amazing.
nice. I think that this perspective really gives a new way of seeing the concept of human-robot teaming and the overall philosophical idea. So was a really, really interesting discussion, Marius. And I
I'm
also
so happy I have this opportunity to talk to you, and I cannot wait to meet you. My former student, who she has a PhD now, and she's part of our team in the Romanian hub of artificial intelligence. Alina Marcu, I think she told me about you. Did you meet Alina by any chance at
probably
RFU?
at the ERF, European Robotic Forum in Stavanger. Yeah, I
Yeah.
remember.
She
Yes.
she told me about you. She was very excited about the discussion. And also you touched on the subject of mathematics. A lot of mothers and parents come to me and ask, Marius, can you try to talk to our kids and convince them that mathematics is useful? Now, apparently, if we live in this world in which everything is working for us, there is no place for mathematics, apparently. But in
Apparently.
reality, all this technology and all our existence, from our internet connection, from our TV, from our phone, to our bank accounts, to our clothing, to our food and prices of the food and supplies, everything deeper mathematics running and going. Now, of course, we don't need a planet full of mathematicians. There's no like 99% of them will do nothing. it's only need for a few, quite a few, selected few who are really talented in mathematics, good at mathematics, and that's what they should do. But but nobody should forget that mathematics is fundamental. It's fundamental. If you want to earn money, if you want to pay less, if you want to live longer, you have to take care of every single detail to optimize everything. And that is mathematics. And that is also a great place for AI to function, to adapt. Because AI could really help us in ways in which we cannot help ourselves. So AI needs mathematics, and we need mathematics. It's a mathematical universe.
I
Mathematics
agree.
is
I really agree.
so amazing. When I teach computer vision and I show my students probably 20 different ways in which a matrix, its eigenvectors, its eigenvalues, its spectral properties, singular value decomposition, least squares, all this basic linear algebra stuff. It's not so complex. It's basic stuff. And you see it everywhere in all these problems, from stereo vision to fitting lines to you name everything. Every time you want to estimate something, you end up with some eigenvector. You end up with some linear system of equation. You end up with a matrix. And that is mathematics. And if you know, it's just so amazing that these concepts, and unfortunately, when they start studying this in school, they learn about matrices, determinants, eigenvectors, eigenvalues, all these properties, but nobody really tells them how useful they are. And they think this is abstract stuff. This is abstract stuff. Why do I need it? When in fact, it's more real than reality itself. It's like it's in everything we see. It's hidden there. It's the mathematics of the universe, and it's much more complex than that. When you think about rotations being represented with quaternions, and quaternions being these creatures that are like so hard to understand, they are more they are crazier than complex numbers, but they are connected directly to our physical natural reality, rotation. What can be more real than a rotation? And inside it, quaternions are the best way to represent it, the best known way to represent it. Or if you go even deeper and you see all these complex mathematics and analysis which are used to prove Fermat's theorem, which is about natural numbers. It's about this nature that looks so innocent, that looks so beautiful and nice and friendly. Behind it, you have things like quantum physics and this complex mathematics that doesn't look anything like natural. But in fact, it's more real. It's so real because it explains what's real. So I think we should pay respects to mathematics, and if children or young people listen to us, not everyone has to be a mathematician. Like, not everyone has to be a Formula One driver. Not everyone has to be a tennis player. Nobody. We all have our role in the universe, but we should understand that if we take out mathematics, we are done. 8 billion people cannot live on this planet. Now, AI, what AI can really do, and now going beyond robots, little robots, AI can really do things that we cannot. AI can monitor the planet at speeds we cannot. It can take information from satellites. It can take information from drones, from sensors that can better adapt and take smart decisions locally, while taking in consideration this global information in order for us to have a better life, to be able to better survive, to have better clothes, cheaper clothes, but better, cheaper food, but healthier planet, healthier air, longer lives. And you cannot take AI and technology out of this equation anymore.
I think
So it's a
this is a
responsibility.
very, very nice message to take home for our listeners and viewers. And I also want to take the opportunity for you, Marius, to connect and maybe reference the work that you have done with Christina Lazar,
Oh
because
yes,
we had
Christina, that's such an amazing work which started. It has a deep connection to what we talked before, because at the
an
beginning of
episode
this discussion,
with
yes,
her.
and Concilio Museum, which is right there in Christiansand, and I don't know if you got the chance, but I invite you to go and test it yourself and see it, because it's a unique system. But let me tell you a little bit about the history. So art is there, right? Christina is a great artist. She has an amazing talent, amazing line. And when I saw her work, I was so impressed. I saw the talent behind the line. I saw this almost like divine calling for beauty and aesthetics, and so profound. Her lines are so perfect. It's like music in her lines. It's almost like a synesthesia of the graphics, what Christina has in her mind and her uh, hand. Now, what is the connection between that and what I was doing? And at that time, it was not clear there is a connection, but to me, it was a clear connection, because I was thinking the same way. And I was looking for this world to be able to connect to me, to connect to my mind. So of course that I would have liked to see these creations being connected to me in a more direct way. So can I, on one hand, can I create in real time? Can I have this art respond to me in real time? So instead of going to a museum in which all these works are somewhere in time with the authors that are long gone, can I bring it into the present? Now, I'm not saying that classic art. No, classic art is classic art and is going to be at this at the top level. But there is so much more mountains that we can conquer in art, right? There are so much more that we can do. Like one, we talked about AI being able to imitate us at different levels, to be the mirror of us, to respond to us in an intelligent way. And that is impressive, because it's like saying, wow, the universe, it's like me and I'm like the universe. So we are, who knows, maybe the universe is alive, in fact. Maybe there is much more than what we can see. So it's amazing. It's a connection. So can I make these non-living things respond creatively, emotionally? Because okay, robots can walk, but can they respond emotionally? Can they respond to my emotions? So that was the first question. And then we created this project called Smile Project, and we started working on it on 2017, 2018, which was really a pioneering work, because there is no work at that time that I know of, no painting that was responding to humans' emotions. Now, of course, that is very hard to say, really, there was no such work, because the world is so big and it's impossible to prove non-existence of something, right? But I have searched and I didn't see anything like that. And after, so what we did was these paintings, and I was thinking, how can I make the paintings respond to me? And around that time, there was this this style in the work of art to put lights on with neon and with fiber optics, to put fiber optics on paintings. There was this trend, and it just appeared right then to put fiber optics. So then so that some works of art would with light, with electricity, with light that were flashing, and it was interesting. But of course, they were not responding to the user. And then I said, okay, maybe I can take this opportunity to somehow make these paintings with these lights, put lights on Christina's paintings, imagine some drawings. And I was also involved in drawing them with we still have my drawings, the notebook. And how can they respond to me? Well, they have to see me first, and they have to recognize. And I said, let's call it Smile Project, so it responds to the smile. Why smile? Because smile is so profound. It's happiness, and it's just, it's like so beautiful. It's like the sun is rising when a human is smiling, and it reminds me even of that famous sermon by Buddha, when Buddha took a flower and smiled at the flower. Look at the flower, and someone from the audience smiled, and in that way the message was transmitted. So it was a message beyond words. The sun, the smile, the flower, and the divine. So I said, can that painting respond to my smile? Well, of course it can. It needs a camera, it needs a computer. And okay, what camera? What computer? So I was thinking of putting a phone, hiding a phone, because I think, well, the best way to have a camera attached to a computer is the phone. See, we're talking about the phone again. And around that time, there was no deep learning system or deep or neural net running on phones. We were still before the era of TensorFlow Lite. That was basically our first neural net that we put on the phone. But when we started, we had to program some basic machine learning algorithms, traditional machine learning algorithm, to detect smile. But then as we were working, TensorFlow Lite appeared. So actually we were able, in the middle of the process, we were able to train a neural net, a small neural net, and put it on the phone. And then at the end of the process, we were able to have 3 neural nets, one that was detecting the pose, one that was detecting the face, and one that was detecting the smile. And it was just right then when it appeared. So of course it was the first in the world because we did it right when that could happen on the phone. So it's very unlikely that someone did exactly the same thing somewhere else. In any case, it's pioneering work, and I'm really happy. We didn't patent it, but it's there at the Institute of Mathematics, and it's documented. So in any case, we had the phone, but then okay, we have to connect it to the fiber optics, and then we did it through this. We had this engineer and programmer who was Nicolae Roșia, who was really great from Romania. He's such a talented engineer and programmer, and now AI scientist and programmer also. So we worked with him, and he connected these Wi-Fi systems that were connected to the phone, and they were connected to the fiber optics. So a single phone was controlling 5 paintings with 5 fiber optics that were responding to the smile and to the gestures and to the body. So it's running even today on Samsung S9. We still have the original phone, and it's running like it was running 8 years ago. And it's just a beautiful thing to see. Okay, so from then on, I was thinking, okay, but I'm limited by the fiber optics, right? So I really cannot make this painting change in real time unless I move to the digital world on the screen or with the projector. And basically what you see at Concilio Museum is a place on a long road.
The
It's not
evolution
the
of
end of the road. It's not the end of the road, but it's the development along the road. So now what that system is doing is basically I'm drawing in the air with I'm sketching, I cannot draw really, I don't have that level of detail. Drawing in the air, and the system in real time is responding and creating art in a specific style. And it's also combined with language. And it's only possible, well, of course, because I dreamed of it, but because the technology of today allows it to be possible, and only today, a year ago, would have not been possible. Why? Well, how do we detect the hand in the air? That is done by MediaPipe by Google, which was running a year ago. Today is running better. But what was not running well a year ago is the capability of the system of generative AI, of diffusion models, to create in real time. So a year or two ago, these vision models took minutes to create the painting. And now we adapted them, and the research reached the point in which they can respond in real time, like 150 milliseconds, which is very close to our human capability of perception. In fact, 120 milliseconds, I don't know if people know, but it's kind of the limit of our ability to perceive and react. Like Formula One drivers, I was mentioning Formula One. I'm very passionate about Formula One. That's why I know a lot about it. A Formula One driver can respond in no less than 120 milliseconds. So that is what real time could be for us human, the limit. And this system responds in 120, 150 milliseconds. So it responds, it creates a painting that combines whatever I'm sketching in the air with a prompt. The prompt is not shown to the user because we don't want to make it more complex for the user, but the user could actually speak the prompt. But we created prompts in the style of the paintings that we want to create. Let's say Pablo Picasso, Cubism, a girl with a forest in the background, vivid colors, oil on canvas, or watercolor or whatever. And we can even combine things that were beyond Picasso's style. We can combine whatever this network is trained on. So we basically describe in a few words what the painting should be about. But of course that the painting is much more than that text, because they say an image speaks 1,000 words. It's more than 1,000 words. So I don't have enough words to actually address to a specific painting. It's just words that could fit an infinite number of paintings. So, but then that is combined with what I draw in real time. But what comes out also has a random number generator inside. And it's also directly related to what the network was trained on. So really what comes out, it's unique. It's like and unpredictable. We actually tested it. And what's interesting is that even if I train it on specific Picasso's paintings or Christina Lazar's paintings, or nowadays, for example, at the museum, we have Nordic painters, Munch and others, and all the famous Nordic painters. We have about 100 Nordic painters. We have about 400 paintings on which we train on with the styles from Nordic. So it's a chance for people from Scandinavia and from Nordic people to go and actually see this system in the Nordic style. But we also had it with Picasso's style. We also had Christina Lazar's style. So and other styles, of course. So the network is trained on a specific data set. And it's trained on specific paintings with specific drawings. Now, the drawings used for training, of course, are not human drawings because we don't have time to ask someone to keep drawing. So what we did is we took the original paintings and we passed it to another neural network, which creates a sketch. So we give a training time, the sketch, the text, and the text is randomly generated, but from the universe of those artists. And then the network is trained to produce that paint. Now, because the diffusion networks work with these random number generators inside, if a test time I give it the exact input and output, it's not going to generate the exact painting. It's going to generate something completely new. And that is interesting and also useful because the original artist's work is protected. So we are not going to destroy anybody's work. We are not going to show Picasso's work destroyed. It's more like we are going to have this network behave like an apprentice. And in combination with the human, it's actually new art. We are the apprentice of Picasso. And we are also creators ourselves. So like this is really interesting.
The school of Picasso, you know, in the...
It's the school of Picasso. But also we can have an integrated school of many artists and many styles because we are actually putting our hands into art history. It's and this is what artists do anyway. We are becoming artists ourselves. Artists play with art history. Artists look all the time. They live in a universe, an artistic universe. They look, they get used to the art history, and then they create. That's why there is no coincidence that different times had different styles of painting, because artists copy each other. To be honest, this is what they do. We copy each other, and that is beautiful. That is nice. We are part of a big earth. We copy each other, and then we create on top of it. We add our unique emotion, unique fingerprint, unique mind, but we also copy each other. So that is no problem to do that. It's no shame. It's no shame. All great ideas in the world are coming to our minds from different directions, and we add something on it. Even the theory of Newton, even the theory of Einstein had its predecessors. Leibniz is actually also credited with mathematical analysis, not just Newton. Before Einstein, you had Lorentz transformations and other things. So it's not like no man is an island, and this is beautiful, and we should accept that. We should go beyond our egos and accept that. It's beautiful. Now, of course, that some of us are more lucky than others, and the names could remain forever while others are forgotten. But in reality, and we keep discovering, There are other discoverers out there that nobody knows about. Like Rosalind Franklin was never credited until recently with the discovery of the DNA, right? But she was there, and she was an important part. And not just her, other people. But let's go back to this system. So this system now, what does it do? I have the chance to create, but also I have the chance to know, to learn from Picasso. I also have the chance to connect to Picasso over time and space in some sense. He doesn't even know that he's part of this, but actually his ideas come to life. It's not like going to a museum in which I walk and I get bored maybe, or I'm not paying attention, because I get involved. I get involved through intention, to action, and I'll never forget that experience. I learn about it by creating. It's good for kids. Kids love it. It's good for people. We move our hands, not just stare like that. Museums used to be, at least in Romania, or at least in my mind, used to be connected to something old because they are about the past. Let's bring them to the present. Let's have that side too. I'm not saying we should replace the room with the great works. No, this is more like a workshop. This is more like a workshop. It's a living thing. Let's have fun. Let's bring AI into this real-time interaction. And it's human-centered. It's human-centered. It's actually following the principles. Is it trustworthy? Well, in this case, it's so benign. It's so friendly. It's not about creating something that's actually that I need to be 100% secure. All I need to be secure about is that I'm not destroying anybody's work. I'm paying respect to the great artist. I'm actually bringing them to the present. So, in fact, I'm promoting art. This reminds me of a great movie that is now playing in the theaters. It's called The Yellow Tie. And it is about this great Romanian, Celibidache, great Romanian director. How you call this? The one who is
Maestro.
Lijor, who is directing an orchestra.
Yeah, orchestra director. Yeah,
orchestra director. He was also a composer, but as a director, he was fully, amazing at the highest level. He was conquering the world, Celibidache. And he had a problem with technology. He didn't allow people to record his performances, to record them, because he said, they're stealing my performance. See, so we have this very conservative way of thinking, oh, you copy me. But then his son says, Father, it is through these recordings, bootlegs, which are illegal because you don't allow them, that I was able to see you in Japan, in New York, in Berlin, in all these places you went. You don't realize that it is for the good and benefit of your art to use this technology to copy it. Because yes, it's not the real performance. Nobody can replace the real performance, but it's the next best thing. Otherwise, that performance is gone forever. Now, I could also see this art that learns in the style of great artists as bring them to life. Let's learn. Let's create new things. Let's have them being part of our DNA. It's not bad at all. It's a way of educating and making education fun. So that is attaching to education. But as the system, this system of real-time drawing, I'm not aware of any other system that is similar in a museum today, because this idea, I didn't get it from anywhere. But of course, it uses components like generative AI, MediaPipe from Google. Then we have also a component that's doing super resolution. Then we have the component that is doing the sketch. We have the learning. So all these technologies is developed in the world of science and AI today, and we are putting them together. But this real time in a museum of drawing, I personally did not see, but I'm not saying it doesn't exist because the world is huge. But I was so impressed when I was there, and it just came up. Let's put it on the big screen. Let's put it on the projector. It's like 10 meters by 10 meters. And when I saw that happening, you know what happened? A new idea came to me. All of a sudden, I realized that I can actually do something that's not done yet, but it's in my plan. I can create stories. How? Well, imagine now that instead of training this network on everything, I could take it and fine tune it on a specific story. It could be, Cinderella story or Snow White story. I take images from the story, and there are many animated movies around there that I could get inspiration from, or I can have Christina draw, which is actually, she's doing that right now, with different scenes of the story. I also have the caption. I have the description of what happens in the story. So I have the story written in a very concise, summarized way. And I have the scenes. So how about I now come and I start telling the story. And as I move my hand, I can go to the next page or I can get back. And I could have a movie of the Snow White story, which I create in my own unique way, because it's going to be the scenes are going to be the scenes in the story, but they are going to be adapted to my movements. So they will be unique. I'll be also an art director for that story. And it's going to be a movie because it's going to change. So at the end, I could actually give the user a movie of his own Snow White interpretation. And when I realized I could actually create stories, I said, we're going in space and time again. It's not just space, it's also time. We can actually tell stories with this system with
Very,
minimal
very interesting.
adaptation.
Very beautiful
And
approach.
then there is another idea, which is even crazier, but we can do it. Is to fly, because I also like to fly. Flying is good because you know why it's good? Because it gives you 6 degrees of freedom. 6 degrees is the sense that you also have the pose, the camera angle, and you also have you have 3D location, you have the camera angles, you also have the time, so it's 6D plus time. And you have so many degrees of freedom, much more than on Earth, to see very complex scenes, much more than you can see from a self-driving car perspective. So a self-driving car or a car, you can close your eyes. What do you see in front? Well, it's probably a street with some other cars in front. So it's not that complex. It's risky. It's risky, but it's not that complex. It's not that interesting. For a drone, a small drone is not risky because it's tiny, 100, 200 grams. And it doesn't touch anything because it's high in the air. It's free space. So it's not risky, but it's complex and interesting. And it could be above anything. So that's why I like flying, and I want to do research from that perspective, because I truly can put easier everything together from the perspective of a globe in the air, trying to see the world from above. It gives me the opportunity to put together depth, semantic segmentation, flight control, navigation. I could even go into virtual reality. Now we are planting avatars in these scenes that are doing different emotions and different communications in order to learn how to communicate to people that might need to be rescued or might do certain gestures from a distance. So actually, it gives the possibility of combining virtual reality with reality, doing this augmented reality for training, but also in the context of art. Imagine you fly over a scene, and all of a sudden you see that scene, Kristiansand. You fly over Kristiansand, and you can see that scene from the eyes of a specific Nordic painter. Or you fly over Barcelona or over some different place, and you see through the eyes of Picasso, or through the eyes of Dali, or through the eyes of Monet. And you transform the scene in real time. And you can also go back in time, because this network could take any image that you can see from the real drone and transform it through an artistic period. So actually, we could even do that. We can. I got this idea that might be interesting to actually have a painted fly, or have or go back in time. Like, could actually take a network that could transform the world of today in the world of tomorrow. Let's fly over a city and all of a sudden transform it into a futuristic city from Blade Runner, or some just have this experience. It would be interesting for users and for people. And what modern AI does for us now is that it could take this into real time. So what only Hollywood directors could do before, now, not in such a great resolution and not at the quality of a Hollywood movie, but still in a decent quality that you can actually, so decent that you can actually enjoy it on a phone. You can have it in real time. You can have it done without having to spend millions.
Yeah,
So
this
yeah, there
is
are great ideas
really,
that we can do.
really beautiful, really interesting, and I'm actually looking forward to see these new ideas coming into reality, Marius. And I would like just to summarize the content of today's episode. And we have gone through like a journey with you, Marius, starting from the analogy and the beautiful connection between mathematics and poetry. And then we have touched concept of vision and perception. And then finally, we have learned more about the connection with art and the possibility of uh, making art become alive and leaving it into space first with your Smile project. Yeah, so I would like to summarize the content of today's episode. We started with the analogy, beautiful analogy between poetry and mathematics, and then we were moving towards the concept of perception, and then into art and the possibility of making art living into space first and time. And I think this is very beautifully connected to the concept of this podcast. And I would like to invite you to leave our listeners with a final message. Maybe you would like to say something or thank you to your team. And we really, really appreciated your very visionary approach to this concept, Marius.
Well, I first want to thank you, Filippo, for this wonderful opportunity to reach to your wonderful audience and to a greater audience of professionals, but also young people who hopefully will take these dreams beyond for a better world, for creating a better world. I also want to thank my students, my team, for making all this possible. We created a dream together. It's a collective dream that we created, and we couldn't one without the other. And thank God that we got this opportunity to meet each other, and to have the resources, and to have the health, and time, and the place, the laboratories, and other people around. It's like such a blessing, and so many coincidences that had to happen for us to have this great opportunity. And not everybody in this world has this opportunity, but we dreamed a lot, and we believed a lot, and maybe that's why we got this chance from God and from the universe. And I want to thank, of course, my parents and Carnegie Mellon, and my advisors and professors, and my advisor Marcel Hébert, for their great advice and wisdom and love, and so many opportunities I got there to see. And United States, so many things I learned from there, and also Romania, and so many opportunities I got into my lovely country. And Norway, the opportunities we have today to develop our relationships with Norway. We have to be so. I mean, I have to be um, so grateful for everything I received. And this is a great time. And I think we should we should all be grateful for these great times, because we can do today what nobody could do before.
Thank,
And
thank,
I tell these young students, don't get lazy. Just take this as an opportunity for you to do even more things that I didn't even dream about when I was your age. So thank you, everyone, and thank you, Filippo. And I can only end my intervention with a positive thought.
very good, Marius. I really appreciated your intervention, and I really look forward to see your new projects coming into reality. And with this, I would like to invite our listeners to follow us in the next episodes. And remember that they are among us, and we are human robot teaming. Enjoy the song, the ending song of the episode that will reverberate some of the topics that we discussed today with Marius. Listen to the lyrics, and thank you everyone for joining us today.
Thank you, everyone. Thank you, Filippo.
Bye-bye.
Through the noise of doubt and distance, through the fear of what may be, we found trust in every motion, in shared autonomy. Not replacement, not surrender, but a fusion of design. Intelligence extended, your decision joined with mine.